Okay, section 8.5, single replacement reactions. The way to tell a single replacement reaction is you have a single element plus another compound. So you'll notice each of these examples has a single element and then it also has a compound. It may be ionic, it may be covalent. What we will need to realize is the metals will switch or the nonmetals will switch. So it will all depend on what the single element happens to be. So in this first example, our single element is zinc, which is a metal. Since it's a metal, it will tend to form a cation. So I want to switch it with hydrogen, which is also the cation, even though it's not a metal. This is one of those rare circumstances. So I'm going to switch the zinc and the hydrogen. So instead of zinc, I'm going to place the hydrogen. In place of where the hydrogen was, I'm going to put the zinc together with the sulfate. So I just switched the Zn and the H. Now I need to check both if I have diatomics or I need to check the charges. So hydrogen, because it is a diatomic, it should get a 2. And then zinc is a +2, sulfate is a -2. They cancel, so I'll erase the charges, and then I'm finished. And this is my final answer. So I have hydrogen and zinc sulfate. Okay, in my next example, I have chlorine, which is a nonmetal, and so it's going to have to switch with another nonmetal or an anion because it's going to form an anion. So I'm going to switch the chlorine and the iodine with each other. And so what I'll end up with is instead of chlorine by itself, the iodine is now by itself. And then instead of sodium iodide, I now have sodium with the chloride. Notice I did not carry forward my 2 on the chlorine. Don't carry numbers forward unless it belongs to a polyatomic ion. So this 2 does not carry forward to here. We need to determine if we have a diatomic and if we need to balance charges, and both are true in this case. Iodine is a diatomic, so it gets a 2. Sodium is a +1, chloride is a -1, and so they cancel with each other. So notice that, and this is my final answer, notice that just because the chlorine has a 2 next to it on the left does not automatically mean it will have a 2 next to it on the right. Same thing with the iodine. We only have 1 iodine here, whereas we have 2 here. It's because here's a diatomic, whereas here, this is sodium iodide. The charge is canceled, leaving me a 1-to-1 ratio. As usual, you should always balance your equation when you have finished. However, we're not going to worry about balancing these. The third example is with calcium. Calcium is a metal, and so it's going to switch with copper because they are both metals. Or they will both become cations. So in place of copper, in place of the calcium, I will put the copper. In place of the copper, I'll put the calcium with the nitrate. I carried forward the 3 because 3 belongs to nitrate. NO3 is nitrate. Now I need to know, do I have a diatomic? Copper is not a diatomic, so it does not need a 2 next to it. If I balance the charges for calcium and nitrate, +2 -1 switch, giving me nitrate in parentheses with a 2 on the outside of it. Erase the charges, and that's my final answer. The last example is aluminum, which is a metal, and therefore will form a cation, and so it will switch with the hydrogen. Metals always come first, nonmetals always come second. So in place of the aluminum, I'm going to put hydrogen, and in place of the hydrogen, I'm going to put the aluminum with the oxygen. I did not carry numbers forward. Now, hydrogen is a diatomic, so it'll get a 2 for that reason. Aluminum is a +3, oxide is a -2. If I switch the charges, I get Al2O3, and then I'll erase the charges, and this is your final answer. In the next section, we'll look at double replacement reactions.